experience. Just want to get to know you guys before we kick off our lesson for today. I think the first person I can see is Chibike Joshua. Hi, Chibike. Good afternoon.
Yeah, I'm good. Good afternoon, sir.
Good afternoon. How you doing?
I'm fine.
Yeah,
So,
thank you. Briefly, yeah, yeah, go on. Go ahead.
okay, my name is Chibike Joshua. I base in Port Harcourt, Rivers State. So currently, I am doing um, web dev, like the front end, and but I want to be a DevOps engineer. So because I noticed that there are some things that you have to do, you have to know before diving into DevOps engineering. So that's it. So that's one of the things that I made me to start, having interest in DevOps. So yeah.
Okay, thanks, Chibike. Thanks. Thanks for that brief introduction. Um, Ayowale, are you with us? You can unmute yourself and just give us a brief introduction. I see your mic is unmuted, but I don't hear anything. Okay, I think Ayowale has an issue with his mic. Let's go ahead. When it's resolved, you can get back to us. Musbaudin, how you doing? Good afternoon.
Yes, good afternoon, sir. Good afternoon, everyone. Thank you for the opportunity to be here, for creating this opportunity for every one of us. My name is Musbaudin Oyedegi. I base in Songo, Ota, Ogun State. I am currently an IT infrastructure engineer, but due to the fact that the IT sector is really revolving fast, right? So I decided to opt in for the DevOps, engineering bootcamp, because I see that infrastructure are now being managed by DevOps team, right? Thank you.
Yeah, thanks for that brief introduction, Musbaudin. Yeah, and you're also correct with your claim that yeah, DevOps engineers too, and now also infrastructure, handle infrastructure on their own. Um, I see Oluwadamilare, that's our meeting host. It's not part of us for the class. Onyeyichi Onyekaba, good afternoon.
Hi, good afternoon. My name is Olivia Onyechinkawa, and I'm based in Lagos. I work as a UI/UX designer and also a web developer. Actually, Elevate is a co-founder on a startup we are building. I'm actually glad to see him here, but I think his mic is having some issues, so he will be able to join us back soon. But I actually decided to just dive into DevOps because I've realized that there's absolutely no way to build a working system in any kind of a SaaS platform, anything without having a DevOps background in it. Which is one of the reasons why I decided that okay, if I want to be a web developer, it's best to have a good idea of what DevOps is all about.
Hmm, okay,
Thank you.
thank you. Thank you so much, Onyeyichi, for the brief introduction. Yes, Ayowale, are you back?
Yes, and yeah.
Yeah, okay, you can go ahead. How you doing? Good afternoon. Can give us a brief introduction.
Oh, hi. Good afternoon. My name is David Ayole Jerry. Uh, I'm a filmmaker, a tech founder, and I have a knowledge in front end and design. So, what made me choose DevOps? I and Onyechi co-founded a tech startup, and I see all the stress that it took to get here. to where we are right now. And I just decided that okay, since I have the skills, I have tech skills already, some tech skills already. Why not just do something else that would lift me from being a non-technical founder to a founder, so to a technical founder. So I first went back to coding, to website design, and then now I'm here to, take it further so that the responsibility is shared and we can make do works faster. Thank you.
Mm, mm. Yeah, thanks so much, Ayole. Amazing background there. I see a couple of people just joined us. Barnabas and Chigozie. Good afternoon, Barnabas and Chigozie. We're just about to start the class, so everyone is introducing themselves. Good afternoon, Barnabas. How you doing? Can you give us just a brief introduction of yourself and why you're interested in DevOps and why you want to join us for this bootcamp? Hi, Barnabas. Can you hear me? Okay, seems Barnabas is not active or he's having issues unmuting himself. Chigozie, good afternoon. Are you here with us?
Good afternoon, everyone.
Afternoon.
Can you hear me? Hello.
Yes, I hear you.
How are you?
Yeah, you're audible.
Okay, my name is Chigozie Agulon. I'm an IT infrastructure engineer. Basically, I work on Oracle servers, HP servers, and storage. Reason for joining this platform, DevOps, is because I've had interest becoming a DevOps engineer. So, like, I'm trying to move from or having more knowledge, not just as an IT infrastructure engineer, because it's they actually seems to be like the same technology, but just so that's one of the reasons why I want to graduate from being an IT infrastructure engineer to also a DevOps engineer. Thank you.
Thanks, Chigozie. Thanks for introducing yourself. Barnabas, if you're back with us, you can also unmute yourself and just give a brief introduction. Okay. Barnabas is at work. DevOps is something you would like to try. He has some experience of web dev experience. Nice to meet you too, Barnabas. Yeah, nice to meet everyone. Yeah, met a couple of. I mean, you guys are amazing. You guys have an amazing portfolio. You seem to me be amazing set of people. Just to give my own brief introduction. For people that were not in the onboarding session we had last week, my name is Bamidele Oluwatosin. I'm a senior DevOps engineer. I have over 5 years of experience in DevOps. Apart from being a DevOps engineer, in the past I've also been a mobile application developer. I've been a web dev also. I think I've also dabbled a bit in graphic design, although it was not very professional. I didn't go into it deep, very deep as a professional career. I've also um, um, I also have experience in business analyst, right? But my main portfolio, which you guys are more concerned about, and I'm more concerned about stating here, is my DevOps experience, right? So throughout the years as a DevOps engineer, um, I've worked with and I've worked on several products, right? So which includes Wemalat 2.0, Momo PSB 2.0, which is being rolled out soon. Um, Rover UK, a subsidiary of FCMB, a couple of other city trusts, Liberia, 21st century in South Africa. My experience is mostly on building core banking applications, right, for banks. Yeah. So right now I currently work with a company where we build games, right? It's a Nigerian company. We build trivia games. It's VDL Tech. You guys can check it out. We build trivia games for our customer. We're also involved in VAS, value added services. Right. Yeah. So that was a brief introduction of myself too. So yes, I think we can go ahead and start our class for today. Our time is fast spent already. So let me try and share my screen. Let's see. It's there. Just to confirm before I start, have you guys gotten the curriculum for the OBU bootcamp?
Not yet. We've not sent it out yet, but they'll get it soon.
Oh, okay, okay. All right, thanks. Thanks for that. All right. So can see. Guys, pardon my convenience. Okay. Okay, I go to go now. All right. Is my screen audible? Sorry, my screen visible.
Yes, yes, it is.
All right. Okay. So, as you guys, some of you might have known already, bootcamp is a 8 weeks bootcamp with 2 sessions for each week. Right. So we're going to be having 2 classes every week. And so is the 8 weeks bootcamp is divided into two. 4 weeks for beginners and then 4 weeks for advanced. So in the previous session we had, the onboarding session, I believe some of the admin guys will have explained the breakdown of that to you. Right. So today we'll be going into our first session, right? So the first session is understanding the fundamentals of DevOps, right? So what is DevOps? What is DevOps? How modern engineering teams build, deliver, operate their products and software. All right. So I guess most of you would already be familiar with tools, right? That we already use in DevOps, right? Because most of you are already into web development. So tools like Linux, Git, Docker. Some of you might even be familiar with CI/CD, Terraform, right, and cloud infrastructure also, right. So first, we need to understand the problem these technologies are trying to solve. So today, what we're trying to do is we're trying to build a mental model, right, for the rest of our bootcamp. Let's go to the next slide. Here, right. Now, journey ahead. So we are 8 weeks from fundamental to a real cloud deployment, right? Now, we need to make sure that we understand concept first before we start working on tools. Every module after this session will build on the mental model that we have built today, right? And on my screen here, I have the bootcamp sequence, right? So we're going to start with DevOps and cloud, understanding DevOps and cloud. Then we're going to go into Linux. Then we're going to Git and GitHub. Then we move to CI/CD. Now, the first four I mentioned is under the beginners class. And then after the beginners class, we move to the advanced. Now, under advanced, we have Docker and Bash. We have cloud infrastructure. We have IEC and monitoring. And then we're going to also be carrying out our capstone projects in the last week for this bootcamp. Now, like I also mentioned, DevOps is not just a list of tools. We'll learn tools, right? But always in the context of the problem that those tools are trying to solve. Let's move on to the next slide. So today's learning activity. At first, we'll define DevOps. Now, what is DevOps? What it means and what it doesn't mean. Why do DevOps exist, right? What are the problems that we have in our traditional product and software delivery methodology? We'll also talk about DevOps culture. DevOps is not just about tools, it's also about the culture, right? Under DevOps culture, we emphasize on collaboration and shared responsibility. It's very important in DevOps culture. And they'll talk about the core practices of DevOps. There's automation, CI/CD, infrastructure as code, which we call IEC, and monitoring. And then last for today, we'll be talking about DevOps and cloud, right? Why are the two commonly used together? So hopefully at the end of this class, you guys should be able to explain DevOps in your own words, right? Not just memorize definition that you see online or whatever I'm going to give to you here. I would want you to be able to explain to someone else or explain to yourself even what DevOps is. How does software reach users? So writing code is not the only part of delivering software, right? Most of us already are web developers. Some of us are already UI UX. Some of us have been in it before, but we stopped. Some of us are just new in it, right? Right. But writing code is just one part of delivering an application, software, or a product. When a developer writes code on a laptop, what has to happen before millions of people can use it? Right. So I want to give you a flow, right? I'll give you a very practical flow that I have used in multiple projects. Right. So say I'll give you a typical project. I would say for Momo Alert 2.0, right? When we're working on the project, there's what we call, this is the flow, right? What I'm sharing on my screen right now is the software delivery lifecycle and flow. Right, and you can see here that it extends beyond just coding. It's not just coding, right? Coding is just one part of the whole software delivery lifecycle. Now, the first thing that did in that project was, okay, we want to improve the alert subsidiary of EMA, right? We have business analysts. They come up with the ideas. Right? What are the ideas, right? Product guys. What are the ideas that we need? What are the ideas for Momala 2.0? Right? Those ideas come to life. To scribble them on a sheet of paper, document them, and then coding begins. Right? We code the application. The developers write the code. After coding is done, they build. Right? And what is build? Building the application. Right? Build the application, and then we test the application before we release it. Now, in the process of testing, we carry out different kind of testing. But do going deep dive into the type of testing is a bit advanced for this level, right? But just understand for now that before an application is released, we carry out tests, right? Now, so those tests can be multiple things. It can be static code analysis tests, so it can be on the code itself. It can be dynamic application tests, right? And a bunch of other kind of tests, right? And then you carry out the release, right? And then the deployment. Now, the deployment is carried out by the operations team. The operations team are the guys that own the server, right? Or the infrastructure where it lives, right? So once that is done, also in the life cycle, we make sure that monitoring is also happening. After operation is done, we carry out monitoring. So the different tools that we have for monitoring are also going to be going into them, doing deep dives, understanding the kind of tools that we have for monitoring, the downsides for each tools, the right tools to use for certain applications, and all sorts, right? And then the last stage is feedback, right? If I had more time, honestly, I would have put this in a circle, right? Because all this is a circle. Because after I've gotten feedback, you then go again with the feedback to create an idea, build code, build, test, release, deploy, operate, and monitor again. Right. So that is the whole cycle of software delivery. Does anyone have any question before we go ahead? No, we have a long way to go, but I can take one question before I continue if there's any. Okay, no question. So let's go ahead. Now, traditional software delivery. Right, this is where we have the developer versus operations. Now you can see there's a breakdown here between development team and operations team. Now both teams are responsible for the same product, for the same application. Right, in this case, let's use a Ala 2.0 for example. They're responsible for the same products, right? Put the development team that are writing the code and the operations team that are handling the servers, infrastructure, and deployment, and all of those, right? So developers are often rewarded for change, right? While operations is rewarded stability. But you have to realize that neither of those goals are wrong, right? But when we have different silos like this in an organization, it can turn our goals into conflicts, right? So development team write the application, they build new features, they fix bugs, they create release, right? The primary pressure would be, or is not even would be, the primary pressure is change speed, right? They always want to make sure that there's speedy deployment. Whenever there's a change that needs to go out, it's done fast, right? And they would also want to carry out experimentation. Right, let's see if this thing would work well. Do you understand? That's their primary motive. That's their primary goal, right? And that's what pressurizes them. That's the pressure that they get from management. Under operations team, they're concerned about running servers and infrastructure, handling deployments, the networking and security of those servers and infrastructure, monitoring the application and servers, or the infrastructure as a whole, and making sure that the applications are reliable, even the infrastructure that the application runs on is reliable. Now, the primary concern and the primary pressure, I would say, is stability of this application, reliability, and also control, right? So you can see that traditionally, these teams have different goals, but they're responsible for the same product, right? Now, this causes the wall of confusion. So developers write code, build application, and they see here the release, and then operation, configure servers, carry out deployment, and then troubleshoot production, troubleshoot whatever issues happen. The customer on the other hand does not care which team caused an outage, is an outage. The application simply does not work. Do you understand? But these two teams have, although they are responsible for the same product, but they have their own separate goals. Right. So imagine something falls, right? And then something fails, right? And then one team is blaming on another team, right? While the other team blames infrastructure, right? And DevOps is here to remove that wall and make sure that there's shared ownership and faster feedback. So that's the whole purpose of DevOps engineering. Okay. Sorry, we had a technical issue. Sorry for the break. Does anyone have a question before we continue? Any question? I always like when class is interactive. Okay, so if no question, I'm just gonna assume that we understand up to this point because there are going to be questions at the end of the class. All right, let's go on. So now I've taken you guys through the traditional approach. What goes wrong with this traditional approach? Right. So the slow releases, what that means is there's large batches with long waits. Before this speed basically is limited. Right. There's a lot of manual processes in this deployment structure or architecture. There's a lot of repeated human steps. We have to run this command, we have to do this, do that. We also have inconsistent environments. Dev, test, and prod might not be the same. Right. Dev might be sitting on a different kind of OS, has different kind of other applications running on it. Tests have different other dependencies, and then prod is now a different environment on its own. Right. And there's poor collaboration, right? Silos and handoff, right? So understanding these silos is very important. So understanding what the solution DevOps is coming to resolve, right? It's poor collaboration between both team, development team, and the operations team. And deployment failures. They're large risky changes, right? You carry out deployments once in 2 weeks, once a week, and these are large deployments that we are not sure the risks. This is my post to our application, meaning we can deploy it now and then the application goes down for some kind of reason because dev and test and prod are not aligned. There's probably some kind of dependency that we needed on this environment and it was not there. Do you understand? So issues like this is what DevOps engineer is coming to resolve. A slow recovery. long troubleshooting cycles, right? We have time. These are issues that I've come across in my career, right? Where we sit down, we have what we call war rooms, and we sit down for hours on end. Sometimes we might run into days, we're just trying to resolve an issue, right? Configuration drift, right? Server becomes different, and the limited feedback. Problem I found too late. It's the job of a DevOps engineer to be able to figure out what an issue might be in the future, right? Predict issues before they happen, right? And then create solutions for those problems. Okay, so how do you do this DevOps process, right? One engineer, 20 production servers, and their manual steps. So now to carry out the deployments, the the developer SSHs into each and every server, install the dependencies, copies the file. If it's Git pull that they are doing, do the Git pull, edit the config. If there's an environment variable change, edit it, and then restart the application. After restarting, the tests, start testing, repeat. What could possibly go wrong? Can anyone give me an answer to that? What could possibly go wrong in this process? From your understanding, what do you think in this process can possibly go wrong? I need one person to answer, so I know that we're following. What could possibly go wrong in this form of deployment process? When we have 20 production servers, and then one engineer carrying out all these manual steps.
I think the engineer might have encounter an issue due to the fact that these 20 servers might have different configurations.
Nice one, Spalding. Thanks. Onyechi, I see you wanted to say something, so.
I was going to say, if one engineer has to handle 20 production servers, it might overwhelm that person, and then they might they might tend to make a mistake along the way.
Yeah. Yes. Thanks so much. Thanks, guys, for your contribution. And we are actually very right. There are going to be there are going to be human errors. Definitely. 20 servers, you have to manually carry out deployments for them. There might be different versions of a package on a server. For example, you're deploying a node application, and then on one node is node 16, and then on the other server is node version 20. Right. This can be a very big issue in production, which I've come across many times. Right. Wrong commands. Because the person is running these commands manually, we are humans, we make mistakes, we're not perfect, we're not robots or machines. There might be wrong commands. It's almost impossible to execute into 20 production servers and all the commands that you run would be correct, right? Now, I'll tie all these issues, right, to toolings and culture that DevOps brings in. Apart from run commands, downtime. Whenever we're doing this, we restart application. There's going to be downtime. Users will say, if it's a banking application, users will say I can't transfer, right? And it's a big issue in production. It's a very big issue in production, right? And also we have difficult rollback. There are issues where after deployments and then something goes wrong, we are unable to find the backup or the previous artifact because it was carried out manually. The person that did the deployment manually might have forgotten to carry out the backup, right? So this is why DevOps is important in any organization, right? Any IT organization, right? Let's move to the next slide. So in all that we have said, what is DevOps? The DevOps is a set of cultures, set of practices, an approach to software delivery that brings development and operations together to deliver software faster, more reliably, and more consistently. So it's simply not the tools. The tools like Docker, Kubernetes, Jenkins, the AWS, the Google Cloud, the IAC, infrastructure as code like Terraform, the Ansible, the monitoring solutions, Prometheus and Grafana, the CI/CD. It's not just those tools, right? DevOps is a culture on its own. And what these tools do is they enable the practice. Now, these tools alone do not create a DevOps because your company, for example, you guys are using Docker, you guys are deploying your application in a Kubernetes environment, or you're using Terraform. Does not mean that you guys are now you guys have updated or you guys have adopted a DevOps culture. No, DevOps is just a set of practices and approach, right? Like I've also defined here. So you can take all what we've said up to this point, and then you can start coming up with your own definition of DevOps. I want everybody to give us their own understanding of what DevOps is at the end of the class. Yeah, so like I said, DevOps is culture, practices, and automation. Now, culture is collaboration, shared responsibility, continuous improvement, and practices. What are practices? These are the CI/CD, infrastructure as code, the monitoring, the automated testing. And the tool, what are the tools? This is the Git. Under Git, we have GitHub Actions. We have Docker. We have Terraform. We have Ansible. We have Grafana. These are tools, right? So tools don't create DevOps, like I mentioned. The people, processes, and culture do. And we have to also understand that culture shapes how people work, right? And practices define how work flows, and tools help automate and enforce these practices. Let's move on to the next slide. Let's see. Okay, apologies for my very ugly diagram. I hope you understand what I'm trying to depict here. So this is the continuous loop of DevOps, right? The DevOps lifecycle. The continuous loop of delivery, operation, and feedback, right? So I think I've mentioned this earlier about the software development lifecycle, right? So this is the DevOps lifecycle. So the plan is carried out, code is done, code is written, application is built, test is done, and then we have this continuous feedback, right? Then after continuous feedback, we have monitoring, then we have release, operate, deploy and operate. Right. First we plan, and then we build, and then we deliver, and then we operate. Then we learn from what it is that we built, and then we improve, and then we repeat. Right. Hope you understand the DevOps life cycle. So at first we plan, and then we build, and then we deliver, and then we operate, and then we learn, and then we improve from what we've learned, and then repeat the process. Okay, so moving on to the next. DevOps is not just to, like we've mentioned, it's a cultural change, right? DevOps does not mean that everybody does every job. It means that teams optimize for the shared outcome, and then they collaborate across the full life cycle, right? So everybody in this life cycle will have to collaborate together. This is not the development team and operations team. They're working in silos. No, everybody will have to collaborate, right? In an organization that practices DevOps, right? So the traditional mindset for developers is my responsibility ends when I finish writing the code, right? Hands off the code. Okay, I've given it to the operations team, let them deploy the application. But the DevOps mindset is we are collectively responsible for delivering value to the customers. So there's going to be collaboration, shared ownership, and system thinking. I'll give you a typical example of this, right? Of what I mean by shared ownership, right? Between this team that I've mentioned. One example is static code analysis. Now, static code analysis is a um is a form of test on application code to see if they meet the correct industry standards, right? And it also checks your application code for things like bugs, security lines, and other things like that, right? That is what static code analysis does. And it's not just responsibility of the developer, it's also the responsibility of DevOps engineer and even operation, right? Because DevOps engineer is going to be the one to set up that static code analysis to enforce it also. Sit down with developers and say, okay, this is the this is the um this is the what's it called? I don't remember what it's called now. But they sit down together basically and agree on a standard, right? They agree on a standard and say, okay, for this 3 months, we'll work on this standard for our code. We make sure that our code is not returning 50 security issues, right? We make sure that for this next 3 months, we reduce our security issues to at least 5 or 1 or 3. And the reason why it's 5 or 1 or 3 can be explained also to the DevOps engineer, right? So you can see it's a mindset, is a thing of shared responsibilities between both teams, right? So it's not just the dev guys or the developers setting up that tool on their own machine. Um, 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 Setting up the standards also, and then saying, okay, this is what our standard is going to be, right? It's a shared responsibility, it's a shared responsibility between both teams. And so that's one example of shared ownership, right? And that is where we need to think as DevOps engineer. Move on to the next slide. We also have an example here of shared responsibilities in practice. So say an application crashes at 2 a.m., right? The traditional response is the operation team will investigate and say it's an application problem. The dev team will investigate and say it's an infrastructure problem. And then the incidents will start moving between both teams. Nobody will want to own it, right? And then the question will not be who caused this, because both teams are not willing to take responsibility for it. What the DevOps response would be to restore services together, to make sure that there's proper use of logs, metrics, and recent changes to identify issues, right? And then afterwards, run a blameless review. It's called a blameless postmortem afterwards. So after everything has happened, the application is back up, you carry out a blameless postmortem, right? And your postmortem, you make sure that you clarify how do we prevent the recurrence of this issue, right? This is an organization, the DevOps response, this is an organization that is adopting the DevOps culture. So you also need to know that introducing a blameless postmortem, it doesn't take out accountability. Accountability still matters, right? Every other team member, every other team in silos, they will still need to be accountable, right? But the objective is to improve the system and controls rather than to create fear or hide mistakes. All right. So we also have the CAMS framework. The CAMS framework. Simplest way to remember the foundation of DevOps. Okay. So what the CAMS framework stand for is culture, automation, lean, measurement, sharing. Right. So culture means collaboration and ownership. Automation, remove repetitive manual work. Lean is small batches, less waste. Right, for deployment. Measurement is use data to improve. Like I mentioned earlier, use your logs, your metrics, data you have gotten, you use it to improve your system. And then sharing knowledge and feedback is very important, right? So you can also use this as a memory aid, right? For example, measurement means we don't also guess whether delivery is improving. We track it through our metrics. Does anybody have any question before we continue? Any question? Okay, no question. So these are the core DevOps practices. So I'm not going to teach each tools deeply here. This is just a map of the territory, right? I'm going to revisit each and every one of them later in our bootcamp. So these are the core DevOps practices. We have 8 of them. You have version controlling, you have continuous integration, you have continuous delivery, you have infrastructure as code, you have configuration management, containerization, monitoring and scripting. Now, what is version control? Version control is tracking and collaborating of changes. Right. So an example is Git. Assume I know most of us want to work with Git already, so we already understand what Git is. But I don't want to do a deep dive now. For those that don't understand what Git is, we have another section made specially for Git. And then continuous integration. Continuous integration means build and test every change. Right. An example of continuous integration is GitHub Actions. I don't know if there's anyone here that has worked with GitHub Actions before. Is there anyone that's worked with GitHub Actions before? Any of the developers on this call? Okay, no. Okay, interesting. So yeah, we'll be going through GitHub Actions also. Continuous delivery, automation of software delivery. An example is the whole CI/CD pipeline, right? From the test, deployment, every single thing, right? We're doing a deep dive in continuous delivery. Infrastructure as code. So infrastructure as code means managing infrastructure with code. An example is Terraform. So what infrastructure code does is, imagine you have 50 servers set up, right? It's going to be hard to go to your cloud console, setting up everything one by one. Say, okay, your boss has told you, set up 20 servers with 10 vCPU, 30 gigabyte of RAM, and 160 gigabyte of space. What is this space? It's going to be hard to start up everything one by one, and even configuring those servers, right? And even other components of the cloud and infrastructure. It's going to be hard to carry them out one by one. So as an organization scale, you start to see the importance and the use of Terraform. So what Terraform does is manages all those creation, all the management of all those infrastructure, creation of the infrastructure, modifying them, and everything regarding the infrastructure using code. Right. So I'm also going to do a deep dive on Terraform. Configuration management. So automate server configuration using Ansible. So Ansible is a tool that you use to automate server configuration. So imagine you have 20 servers, right? And you want to install Node version 20 on each of them. Now the task might be more complex than just installing Node, right? This is where we use tools like Ansible, right? We automate the server configuration. Any configuration that we need to carry out on the server, Ansible is a very good tool for that. I've used it. I've used all these tools that I mentioned here. I've used Ansible too in the past. Currently don't use it. Yeah, I use Terraform for my configuration management, but it's also good to understand Ansible, right? Then containerization. This is a very interesting part of DevOps, right? Packaging applications consistently. Now, typically, what traditional organizations do, that's organizations that do not use containerization. What they do for deployment is they just take their application, if it's a node, they install node on the server, node 13, node 16, node 21, node 24, whatever version it is. They'll have to go and install it on the server. Whatever dependency the application might need would then be installed on the server. But what containerization comes and does is It packages your application to run on any machine, right? That's basically what it does. We're also going to be doing a deep dive on containerization. An example of containerization is Docker. Docker is a tool we're going to use for containerization. We're going to use Docker to package our applications where we don't need whatever host machine we are deploying to. Our application is not going to be dependent on that host machine for it to run, right? All the dependencies would be packaged together in a Docker container, right? And deployed on any host machine, and it would work fine. And then we'll also look at monitoring, right? So understand production health. There are times where issues happen, right? Give you a typical example. Transfers are not working, right? But you don't want customers to be the one to start going on Twitter and say, oh, the transfers are not working, GT Bank transfer is not working, right? So this is where monitoring shines, and it's very important, right? To understand and to detect issues, right? Fast, even before users start complaining. And then we have scripting. Scripting, an example is Bash and Python. I believe most of us would already know of Python. Some of us might have written Python before, might have not, might just be familiar with Python, right? So we're either going to be going with Python or Bash for scripting, right? So scripting is to automate operational tasks, right? You have a bunch of things that you need to do. So writing them one by one, right? You can put everything into a script, right? And automate it using either Python or Bash scripts. Okay, any question for me? Any question? Anybody want to add anything to our class? Or feedback? Any feedback? Any feedback? Okay, no feedback. Move on to the next slide. Okay, automation. So automation, like I mentioned, is a core DevOps principle, right? And now you can see where automation shines. If a process is repetitive, predictable, and frequent, that process is a strong candidate for automation, right? Automation can create consistency and an audit trail of what happened. So you can see in this slide, there's a manual and there's automated. So for manual, the engineer SSH into the server, run commands, edit configuration, deploy, right? This is slow, is error prone. We already spoke about that earlier today, right? So as a core development principle, we need to make sure that any process, like I mentioned, like I said, that is repetitive, predictable, and frequent should be automated, right? So push when a code is pushed, pipeline kicks off, build and test is carried out, deployment is done, and health check is done. So this process is fast, repeatable, and auditable, right? It's fast because the machine is the one carrying it out. You don't have to SSH yourself into any server. Do you understand? It's repeatable because you can easily just go to your pipeline dashboard and repeat this process again. Whenever code is pushed, process is repeated. And it's auditable. It means we see a log of all the deployments we've done on our whatever pipeline or automation tool we decide to use. We're going to see the list of everything, and then it's auditable. We can check, okay, this is where an issue happened. This is where we deployed this. This is where we can carry out a rollback to, you know. So this is what automation is about. Before and after DevOps. So before, developers write code, right? They create a zip of the code. They give it to the operations team. The operations team carry out a manual deployment. Any failure is discovered late after deployment, and then a manual rollback is then carried out. You can see this process is slow, risky, and stressful. So what DevOps doesn't magically eliminate the failures, right? It aims to make the changes smaller, the process repeatable, and the problems visible, right? And should be able to recover faster from issues. Now with DevOps, like I mentioned in the last slide, the developer just pushes the code. There's an automated test carried out with feedback, automated build with feedback also. And there's a controlled deployment. Not just anybody can carry out deployments. And there's monitoring also automated that verifies the health of any application. So this process is faster, as we can see. It's repeatable and is observable. Why should organization adopt DevOps? Does anyone want to help me with this slide? Let's all try and take us through this slide. Anybody? Why organization adopt DevOps?
I think I can give it a go.
Okay, thanks very much.
Okay, so organizations need to adopt DevOps because they need to be able to deploy faster, and because sometimes deployment takes weeks, months, and it's mostly because they have to repeat processes. So if they have DevOps, some of these processes can get easily automated. And if a process gets automated, they won't have to repeat, like they won't have to start making these consistent changes or repetitive changes, which will reduce the amount of changes they will be making. And they will also have to be able to like collaborate within themselves, because now they have an automated process. They know, like each team knows which team to communicate with. And also DevOps makes their products be reliable, because with DevOps and with automated processes in place, they'll be able to detect issues earlier. And if an issue is earlier detected, it fastens the process of rectifying the issues. And when they have these automated processes in place, they have this consistency in the way that they do their own um, operations. Like they have this really like a really balanced environment within all teams. I don't know. That's all I have.
Thank you, thank you. That was very, very good explanation. Yeah. So the explanation shows that you are already getting a grasp of DevOps, and I hope all of us too are already taking that mental note of what DevOps is all about. Right. Before we start going into the practicals, running commands, understanding these, running into issues and the troubleshooting, we need to make a mental note of what it is that we're going into. Right. So thanks again, Onichi. Um yeah. So Onichi was practically right. Right. So to connect all this together and see that, for example, consistency comes from automation, right? To be consistent with our application delivery, we would have to automate first, right? And it also comes with containerizing our application, right? And using infrastructure as code. Like I mentioned about containers, right? Is so containers means container applications where all dependencies have been packaged together to run on its own without depending on the host machine is running on, right? And infrastructure as code, as I've also made us understand, is the automation of infrastructure management. That includes our compute. I gave an example of compute when I was explaining IAC, but it can also go into things like our networking components, our S3 buckets with AWS. Every single component, right? It can be it can be automated, it can be managed, created using IAC, infrastructure as code, right? So that's where consistency comes into, right? Using these tools means that our product, our software is consistent, right? And then we have faster recovery, faster recovery or monitoring. When we monitor our application properly, there's faster recovery, right? And then from small changes that we carry out, we don't do bulk deployments in DevOps, right? I always myself personally advise against it. People that don't understand DevOps principles would not know the risk of large changes to a production environment, right? And also rollback capability. So these are reasons why organizations adopt DevOps. I hope you understand that. So how do we know DevOps is working in an organization? These are four commonly used software delivery performance metrics. Now, deployment frequency. How often do we deploy? Lead time for changes. How long from change to production? Change failure rates. How often do changes cause failure? Time to recovery. How quickly do we recover? The goal here is to move quickly while maintaining reliability, right? The answer to these questions will tell you if you're an organization, DevOps team, or has already adopted the DevOps practice, right? If we are deploying once a week, we're not deploying every day because as a DevOps engineer, we would want to make use of CI/CD, right, for automating deployments. So that would give developers confidence to push out deployments to whether a test or a dev environment more frequently, right? Because of the manual process that has been eliminated, would get more deployment frequency. Lead time for changes would be able to push to change more fast, more quickly. Now, how often the changes cause failure? An organization wherever they deploy and there are a lot of failures, we already know that DevOps practice is not being adopted there. And time to recovery, whenever an issue happened, how quickly does the product recover? So you hear the product has been down for 2 days, right? Should not happen in a team, in an organization where there's a DevOps team, or an organization where they adopt the DevOps practices. You understand? So these are commonly used metrics to determine if DevOps is working in an organization. Okay, so now I'm going to DevOps and cloud computing. These are different concepts, right? But they're powerful together. So DevOps focuses on how we build, deliver, and operate software, right? It's more focused on the culture, the practices, automation, and then feedback. But cloud computing on its own is just to provide computing resources on demand. So cloud computing is just focus. Their concern is servers. We need to create a server. We need to create a storage, an S3 bucket, an EC2 instance, an RDS database. We need to set up Route 53 for monitoring, for networking rather. We need to set up some managed services for our monitoring, right? For our Kubernetes, for what other managed services are there? RDS, the Kafka service, all those things. These are what cloud computing is concerned about. They're not concerned about your automation, the culture and practices of DevOps, right? But DevOps and cloud infrastructure come together to make a fast, automated, and scalable delivery. So DevOps and cloud are not synonyms, right? Cloud makes infrastructure programmable and on demand, which pairs naturally with automation and infrastructure as code. Hope you understand that. How we're bringing cloud and DevOps together. Okay. So yeah, traditional infrastructure versus the cloud. So this is what the traditional infrastructure looks like. They need another server, they purchase hardware, they wait for the delivery. I wish I had an image where I can show you what the traditional infrastructure process looks like, but maybe you guys can do that research on your own, right? So in traditional infrastructure model, they need a server, they purchase the hardware, they wait for delivery, they connect the racks, they install the operating system, they configure network, they configure application. This can lead to potentially days or weeks. It takes time. It takes time. Now, this traditional infrastructure is what companies were using 20, 25 years ago, right? But also companies still use them because of government policies, right? Some companies still use traditional infrastructure, right? I know some companies that do. I think MTN does. I think I've been to one of their what's it called again? The way they had all their physical infrastructure
Data
and
centers.
data centers. Exactly. Thanks. One of the data centers somewhere in Ikoyi. Let me know where the data center is. But other organizations like Netflix, Google, um, um, modern organizations, right? When they need a new server, they create it using web console, CLI, API, or infrastructure as code. Right. Even us, when you want to create a server, you're not going to go and start purchasing a rack now and start connecting it. Although some of us might have our own in-house, what's it called? Our own our own servers in our house and all those stuff. I mean, I don't have it. I'm also concerned about having that. But if I want to create a server, if I need to create any infrastructure components, I just log into my DigitalOcean, my AWS, my GCP, right? I can use the web console easily. Or if you CLI, I want to use an I can easily use that to create the tools that I need, the components that I need. So if it's an easy tool, I can easily just do that, right? So what this does, it potentially eliminates the days or weeks we have to wait for before we start deploying application. We can deploy application within minutes or seconds, right? Now we also have to understand that cloud is not just always instant or always better, right? But the main point here is to explain and show you that cloud exposes that infrastructure is programmable, right? And it's on demand. And this is why it is highly compatible with DevOps automation. And that is why we are we are going to be teaching or doing a little bit of deep dive on cloud itself. Okay. Any question? Okay, no question. So this is the modern DevOps delivery flow. You will learn every layer of this flow during the postcamp, right? From the developer pushing the code, using Git, CI/CD, containerizing the application, deploying that container into a cloud component somewhere, um, and then setting up the application and then monitoring and then getting feedback, right? I mean, if some of these you guys don't understand it, by the end of the bootcamp, I'm sure you'd understand how these pieces fit together. Okay, let's move on to the next slide. Take a peek at the time. Okay, we still have a little bit of time left. Quite a bit actually. Time left. Okay, so what do DevOps engineers actually do? Right, so the job title varies. So in some companies, DevOps engineers, platform engineers, SRE, that's site reliability engineer, cloud engineer. The exact responsibility might differ depending on the company, but these teams are going to reoccur in these job titles that I've mentioned, right? Um, where I worked before now, job title was infrastructure and DevOps engineer, right? So that's DevOps engineer. We manage all the processes here, right? I've worked as an SRE, right? A site reliability engineer. I just took on the same responsibilities, right? The infrastructure, the automation, the CI/CD, all the um, concepts that I mentioned here, right? Although you might just focus on some a bit more. For SRE, for example, you would be focusing more on the monitoring and then the reliability, right? For DevOps engineer in some companies, you might just be focusing more on the automation and CI/CD, right? Doesn't mean that you're not involved in anything regarding monitoring or reliability. These are things that DevOps engineers do. Everything mentioned here, right? So from infrastructure, the cloud, the compute, networking, automation to remove repetitive work, CI/CD to build development pipelines, container to package and run applications, IAC provision with code, monitor to monitor with logs, metrics, and alerts, and then reliability, keep system available, and collaboration. Very, very important. You work across teams. You work across teams. So these are things that DevOps engineers do. Also need to take note of that and understand it. So what's the DevOps engineer toolbox? Right. So these are concepts that you should just learn first. Learn the concept first, and then we'll learn the tool later in our bootcamp. Right. So operating system, you need to know Linux, right? Version control, you need to know Git, GitHub. I think I've explained GitHub already. CI/CD, after CI/CD, the tools that we use for CI/CD, GitHub Actions, Jenkins, Bitbucket pipelines, that one, GitLab pipelines, and so on and so forth. Containers, would make use of Docker for containers. Cloud, so cloud, the different cloud providers like AWS, Azure, GCP, DigitalOcean, Etna, Huawei Cloud, so on and so forth, right? Infrastructure as code would make use of Terraform, right? Doesn't mean that's the only infrastructure as code too, right? But would make use of Terraform. And then for server configuration, would make use of Ansible, right? And then for monitoring, would make use of Prometheus and Grafana. And this does not mean that these are the only tools, right? For operating system, for example, Linux is not the only operating system, right? As a DevOps engineer, I've worked with Windows operating system before, right? I work with different Linux distribution like CentOS, Ubuntu, Red Hat, Enterprise Linux, and so on and so forth, right? And then yeah, you'll be working with different operating systems, right? But this is just a summary of the tools that we'll be going through in our class and throughout the bootcamp. Okay, the practical case study of you being in the DevOps team. Now, we have a fintech application, right? And then we have 100,000 customers, and then we carried out Friday deployments. So this session is going to be interactive, right? It's going to be interactive. So last Friday, a deployment was made, and the application was unavailable for 2 hours. Hello, am I audible?
Yes, yes, sure.
I'm audible. Take my network picking up for a while. This is a practical case study, right? This is a practical case study for a company that's carrying out a deployment on Friday, right? And we have it 100,000 customers on, let's say, OP. Now, testing is mostly manual, right? Application files are copied manually. There's very little monitoring. The engineer SSHs into production. Server configurations are maintained manually. dev and ops, mostly we only talk when something breaks. So can someone not just someone, I want everybody actually to interact. Um Look at the processes, these six processes, right? These six different processes. Can you pick one and then just see what you can what should be improved, right? Based on what we've gone through, which of these processes do you think can be improved? Is it copying the application files manually? Or if you want to, you can go for everything, you can go for everything. I just want us to be which of this process can be improved? Okay, Maz Baldin. Sorry, I don't know if I got your name right, Maz Baldin.
You can just call me Musbel. Musbel is fine.
Oh, sorry, I'm so sorry, Maz Bal. Richard again, sorry.
Yes. So
All right.
let me go with I'll go with the application files copied manually, right?
Mm,
So just from what you have explained so far, right? So the development team, of course, they are busy, building the software, right? So after building the software, right, you then copy the application files manually to the production server or to the staging environment where the testing team needs to test, right? So
mm,
doing these processes manually is time taking and something can go wrong.
mm,
So where DevOps can come in is to automate the process, whereby you mentioned about GitHub action, whereby when the developer finish coding and testing is being performed, and the static test on the code is being performed, and they can easily push to GitHub, and GitHub action, which is one of the Git tool, can handle the automation process and deploy to maybe the staging environment or the production environment.
mm, mm. Thanks, Musbal. Thanks, Musbal. Thanks. I see your solution. Um, the solution spoke to the applications file being copied manually, the testing, um, the engineer execution into production, right? So he spoke to three, right? But he left room for monitoring, right? Monitoring. If the application breaks or there's an issue with an endpoint, what happens, right? Um, and also dev and ops, right? They need to be a collaboration. In typical organization, you have what we call a release change, right? So whenever every organization define what is it should be like, right? Before any deployment is done, certain people need to be notified, right? So depending on the kind of deployment, for a kind of deployment like this, the deployment to production, right? For a fintech application, the DevOps engineer is responsible. The team lead for dev is responsible also. And they need to be notified before any deployment is carried out, right? And they also need to be on standby. Of course, there's a CI/CD pipeline, like Musba has mentioned, right? CI/CD pipeline will carry out that deployment to also do statistical analysis to make sure that we are not carrying out, we are not moving bugs to production, right? We are not moving security issues to production, right? And we're also eliminating the use of engineers SSH into production, right? We don't need an engineer at this point to SSH into production to do anything. We have automated the copying or the transfer of the artifacts into the production environment, right? So yeah, thanks, Musbao. Thanks, Musbao. Anyone else want to make an attempt? Michael Abel, are you with us? Okay. Does any other person want to try?
Sorry, I,
Okay.
I just want to say I think the whole process should be automated. You can't say testing should be the only automated process, or monitoring or copying of files should be the only automated process. if the whole process is automated, I think if there will be a downtime, it won't be as long for as 2 hours.
Mm,
That's just my opinion.
thanks you. Yes, thanks for your contribution, which Miss Power. Any other person want to contribute before we quiet? Okay. Okay. All right. So none of the recommendations that we give are actually wrong, right? They're actually very correct, right? And these are processes. These are loopholes that DevOps culture eliminates, right? So from the monitoring to the copying of applications file manually to the testing, whether it's SAST, DAST, dynamic application testing, or the engineer has it into production, which is very wrong and laughable. And server configuration maintained manually, right? And dev and ops not talking to each other and something breaks. It's very bad, especially when a deployment is going into production, right? There should be constant communication between dev and ops, right? Constant communication. Okay. Okay. So let me send something in the chat so you guys can check. Now let's go ahead. Right. So when we have proper DevOps lifecycle in place, we're not going to have issues where we deploy to production, right? And the application is unavailable for 2 hours. These are issues that I've come across before. I'm not even going to lie. As a DevOps engineer, you go into an organization where they're practicing all these things, and then to change it is going to be it's going to be hard because applications are already live. It's something I would even say I'm facing currently. Right? It's a painstaking work to do, but that's the job of a DevOps engineer, right? Okay, let's go on. I think our time is actually fast spent already. All right, so already did our group discussion. I'll move on to the next. So this is a better DevOps approach, right? And it's also in line with what some of us have said, right? So this is a better DevOps approach for deployments. Version control, we track every code change using Git. Automated tests, we catch issues earlier, right? We have CI pipelines to build and test consistently, and then we have CD to automate deployments. And then we have infrastructure as code to make infrastructure reproducible, right? So if there's any new server that we need to create, any new configuration, you have infrastructure as code to quickly do that and make sure that if any infrastructure goes down, it can be easily reproducible with IEC. So you have to also understand that the use of one tool does not fix the scenario, right? The solution combines the use of DevOps culture, automation, the practice itself, and measurements. We understand. Um, Also shared responsibility and monitoring. Monitoring is very important in any system, whether it's a production or dev environment. You need to observe your availability, errors, and latency, right? And also shared ownership, like I mentioned. So shared ownership, dev and ops jointly own reliability. Now, this can be translated differently in different organizations, right? In the organization where I currently work, setting up the um, um, change management procedure, right? So it's going to define how we carry out deployments. You understand? Who owns what? Who should be responsible for what? Do you understand? And also post incident learning, improve the system after failure. Now, as a DevOps engineer, when an issue happens, you just make sure that you carry out an RCA, root cause analysis. Say, okay, this is the issue that happened. This is how we're going to improve, right? I don't think we have RCA in our curriculum, but I might be taking you guys through it. How to produce an RCA. Okay, let's move on. Let's move on. All right. Quick knowledge check. This one, everybody's going to answer. Everybody's going to speak. So everybody, please just look at the slide I'm presenting right now. So in DevOps with two, what two areas does DevOps combine? Name three DevOps principle. Why is automation important? DevOps versus cloud. What is the difference? So everybody needs to answer. I want us to give our own understanding of everything we've learned so far. Give me answers to these questions. Well, we're calling names, so I'll make sure that everybody answers.
Hello.
Barnabas.
Can I? Okay.
Okay. Sorry, GBK.
Oh, I want to answer the question one. It says, is DevOps a tool? No, it's a culture and a
Okay.
collaboration. So that's what I understand by DevOps.
Okay.
Yeah.
Okay, thanks. Well, you don't answer everything. Everybody's answering everything.
We're answering everything.
Yes, answering everything.
Okay, the two. What two area does DevOps combine? I think the automation and deployment. Yeah. I don't know if I'm correct.
Yeah,
Huh?
so it really combines development and operation.
Okay.
The two areas that DevOps combine.
Okay,
Yeah.
development. Yeah. So then three DevOps principle. The principle.
Let me help with that.
Can I
Um,
answer automation? The importance of automation
okay,
for
go
time
on.
saving. You don't need to waste your time, delaying, what will take you like, let's say 4 hours, with automation, you just, like an hour, and you're done. So that's it.
Okay, okay. Can you answer the last one? The fifth question. DevOps
Okay.
versus cloud. What is the difference?
DevOps is, I think it is built, they build a software, and they focus more on collaboration. Yeah. So cloud is mostly on. I think this cloud is it's just online, like remotely, done remotely. This is what I understand. Like AWS, Microsoft Azure. Like that's all I can say for now. The little knowledge I have. So yeah. So
Thanks.
that's what you can say. Yeah. Thank
Thanks,
you.
Shivik. Okay. Musbah and Oyuchi they have their hands up. But before you guys go ahead, I want to call Michael Idel. I don't know if you're back now.
Good evening.
This is Michael Idel. Hi, Michael.
Can
Good
you hear me?
evening. So just go through the questions on the screen. Answer
Good
anyone
evening.
that just make an attempt.
Okay, okay. Though the network was kind of breaking, but the little I heard, I will just say. So number one, said it's devil's it too. According to your explanation, it's devil is not a tool. It's a culture. It's to unite both the developers and the operating system to bring a seamless production. For number two, what are the two areas? What two areas does devils combine? It combines the the development part and the operating systems. The development parts are involved in the planning, the building, and creating of the code and everything, application and testing. The operating systems, they deploy, monitor, and okay, that's what I know for that now. So for number three, it said, can you hear me?
Yeah, I can hear you. Go ahead, Michael.
Okay, it said name three DevOps principles. Okay, think that one is somehow. But okay, one of the principles is automation. Number two, it unites both the development and the operating parts. And I think that I can only mention two for now. And for four, why is automation important? Okay, for fast, to make the system fast, the production fast, and okay. Then DevOps versus cloud. Okay, I think cloud is like a place where we sort of buy, like a server, something like that. Like you mentioned the EC2 and other tools inside. Then DevOps is the team. DevOps is the team that has to do with the production, the maintenance, the monitoring, the what's it called, the testing and everything. While the cloud is like a place where you deploy, I don't know, like a server. Let me use that, like a server. That's what I understand for the now, but I will repeat the video again because of network. Thank you.
Thanks, Michael. Thanks for the attempts. Thanks so much. Okay, I think Musbah, you can go now. You already had hands up.
Oh, okay. Okay, sir. So for the first question, right? So yeah, just like the first and second presenter have said, so DevOps is not a tool, it's a culture, right? It's a culture and collaboration with the department stakeholders, the development, the DevOps engineers, and other teams involved in making sure the product is successfully deployed, right? The second question is, what two areas does DevOps combine? Yes, from the name, DevOps, that is the development and the ops operation. So these are the two things it combines, the development and the operation. So in the development, we are talking about the software build itself, how the developer build the software, building the software to releasing it, while the operation is the infrastructure itself, how this release is being deployed to the server and maintained, right? And for the third question, which is name three DevOps principle. So from your explanation so far, example of DevOps principles are collaboration, communication, which is very important, automation, right? The CI/CD you have been mentioning too. Number four is, why is automation important? From the explanation so far, we got to understand that companies integrating DevOps in their organization helps to reduce human errors. It helps to speed up deployment and testing. It helps to avoid unnecessary downtime. Right? Yes. And the last is that I can think of for now is it allows teams to focus on high value tasks than trying to troubleshoot when it something happened with the application, right? So the last one is DevOps versus cloud. So what is the difference? So what I understand by that is that from DevOps, we get to understand that it is a culture, a practice of building and deploying software, right? Why the cloud is just a platform. We have different cloud platforms, just like the example you have mentioned. We have AWS, we have Azure, we have Google Cloud. You talk about Hesna, that you've worked using Hesna and GCP server, Google Cloud server as well. So they are cloud platforms, right? Why yes,
Is it my network or is my browser network? Okay.
I think it's his network.
Oh, okay. All right. Onyichi, we can go ahead with you.
Okay. Um, it's DevOps is not a tool. It's simply a culture and a set of practices that is supported by tools like the Terraform, Docker, Jenkins, and the like. So it's simply a way of working that brings development and operations together to deliver software in a more efficient way. Yeah, in a more efficient way. And the two areas where DevOps combine is the development and the operations. It's where people that build a software and the people who run and maintain a software comes together. That is like why it's a combination of development and operations. So that way they will be able to share responsibility equally, and they will be able to like stay in communication instead of like in the last scenario you portrayed about the fintech problem where DevOps engineer only talk like once in a while. They only speak when there is a problem. When there is a good DevOps system in an organization, the whole team work together. Both the development team, the operations team, they all work together instead of working in silos. And three DevOps principles. We have the automation, continuous integration, and continuous delivery. That's the CI/CD, and also there is a continuous improvement. And all of this is actually a way to like make sure there is a good operation system for a particular product or in a particular organization. If there is no automated process, if there is no way to integrate and release small changes frequently, if there is no way to learn from past issues or failures, there will be a good operation managing system in an organization. And number four, why automation is important. Every organization needs automation systems because, as usual, it makes work faster, repeatable, and also it's susceptible to less error. Unlike we humans, when we get overwhelmed, we are prone to errors like easily. But with automation, processes don't like they are less susceptible to errors. And also automation process, I think personally, I think automation process also help detect issues early in a system instead of like having to sit down and go through hundreds of files to see if there is a particular problem somewhere. With an automation system in place, I think errors will be able to like be seen or detected in the early stages before it becomes a bigger issue. And number five, the difference between DevOps and cloud. I think DevOps is the how, why cloud is the where. DevOps is how a system or a software is built and delivered. Why cloud is where you run like everything concerning computing resources. It's where you get them, where you use them. It's more like saying a house and the stuff that goes into the house. Thank you.
Thank you so much. Okay. Thank you everybody for your contribution. I see Ayowale also dropped his contribution in the chat. That's well acknowledged. Thanks, Ayowale. DevOps principle, collaboration, automation, continuous improvements. Yes. So none of the answers we gave were wrong. Everybody gave very good answers, and I'm glad that at this point we'll be able to learn quite a few things about DevOps, right? So the answers that we gave. Um, so is DevOps a tool? No, DevOps is not a tool, right? We all answered correctly. So what two areas do DevOps combine? Development and operations, right? Like we've we've come across, we've mentioned, we've taught ourselves, right? I would like to say that we've taught ourselves, right? The two areas is development and operations. So the examples, we all give very good examples, right? Collaboration, automation, the measurements, the sharing of responsibilities, continuous improvement. Yes, these are all DevOps principles. Um, why is automation important? Automation is important because of the consistency, right? And the lack of human error, like Oyeshi mentioned too, is an important part of why we automate. The speed also and repeatability. Those are also reasons why we automate. DevOps versus cloud. Yes, we all give good answers as to DevOps versus cloud. So DevOps is an approach to the delivery, right, of our software, our products. While cloud itself provides computing resources, infrastructure resources on demand, right? What is on demand? On demand means if I ask for it, I get it. It's not like a traditional way I have to, like, you want to buy a laptop or you want to buy a server rack, you have to make a request for it, get it, you have to install it physically, right? You have to provision the all the resources it's going to use, where it's going to stay, electricity is going to use, you understand? So you would have to provision all those, right? That is the benefit of the cloud. The cloud provides computing resources, infrastructure on demand, right? So that's the difference between cloud and DevOps. So thank you guys for your contribution. For the next slide, I would have to stop sharing my screen for a bit. Just a minute. It's also an interactive session. Also an interactive session. Just give me a minute. If you wanted to take this out, I forgot to take it out. Okay. Let's do this instead. Okay. Share my screen back. OHS, your hand raised. You have a question?
No, that's done. Thank you.
Okay. Right. Okay. Okay. Let me know if we can see my screen. Can we see my screen?
Yes.
Okay, thanks. Thanks for acknowledging. All right. So can we identify the DevOps practice? On um push, every code push automatically runs 500 tests. What DevOps practice is that? Servers are created from Terraform files. What DevOps practice is that? Engineers receive alerts when error rates rise. What DevOps practice is that? Dev and Ops jointly investigate an outage. What DevOps practice or culture is that? A release deploys after all checks pass. What DevOps practice or culture is that? Anyone, do you have any takers? Do you have any takers? Any takers? Anybody that can attempt to identify what DevOps practice? Anyone, not everything. If you know anyone, you can just say, sit down, start everything. I see your feedback. Welcome back. Okay, anybody?
I
Okay, go ahead.
I'll take number one.
Number
Uh,
one.
yeah, the every code pushes automatically after 500. Automatically runs 500 tests.
Hmm.
It's I'll say it's an automated process. That is a CI automated testing.
Hmm.
Like every change that is like made is automatically tested and it's automatically integrated. So I'll say it's a continuous integration practice.
Okay, thanks for everything. Um, any other person? You have any takers? Nobody wants to. You can drop it in the chat if you don't want to unmute though. If you know it and you want to just mention it, but you don't want to unmute, you can drop it in the chat. Okay, Muspa, you can unmute as well.
For I'll take the second one, which is this. Servers are created from Terraform file. That is infrastructure as a code, right?
Thanks for that as well. That's correct. Oyechi, I see you want to go again.
Yeah, I'll take number four. It's still the same thing as the last like it's one of the issues from the last scenarios like you portrayed. DevOps and Dev and Op jointly investigating an outage. I'll say that's a collaboration practice, like
Hmm.
a shared ownership of the problem. It's not that it's just dedicated to a particular team to investigate.
Yeah. It's very good. Any other person wants to try? Barnabas, Chibiki, Michael, Chigozie, Ayole, anybody, even if it's the one that, as we mentioned already, you can still make an attempt. Okay, Musba, let's go ahead.
Yes, for the third one, which is engineer receive alerts when error rates rises. That is for monitoring.
Okay, thanks, Musba. Yes, so we've gotten answers for 4. That's good enough. Okay. All right. So what are the answers? These are the answers, right? No answers were wrong. None of the response you guys gave was wrong. So every code pushed automatically runs 500 tests. That's continuous integration and automated testing. That's correct. Servers are created from Terraform files. That's infrastructure as code. Engineers receive alerts when error rates rise. That's monitoring and observability. Dev and Ops jointly investigate an outage. That's collaboration and shared responsibility, right? And it release deploys after all check passes. That is continuous deployments. Continuous deployment comes after CI. So thank you guys for your contribution. Yeah, nobody was wrong. Um, we are almost at the end of our class. It's almost time. So I'll wrap up the many slides that we have. Common DevOps misconception. Some people think DevOps means using Docker, which is wrong. DevOps is just another name for system admin, which is wrong, right? Developers should do everything. No, developers should not log into the production environment and then deploy applications by themselves. Buying DevOps tools means you are doing DevOps. Doesn't mean you are doing DevOps because you guys purchased monitoring tool, let's say Beta Stack, right? Or you containerize your applications, or you start using that tool is out there, Kubernetes, to manage your containers. That doesn't mean you guys are operating, your organization is operating on DevOps culture, right? DevOps eliminates operations. No, DevOps does not eliminate operations. DevOps is a culture. an engineering system for fast, reliable, collaborative software delivery. Right. So this also emphasizes everything that we spoke about in our lecture today. So since today's big picture, 5 things to remember. Right. You can take your screenshots if you want. DevOps comes from development and operation, but it's bigger than a team name. Right. So DevOps was created because of development and operations, the lack that these two teams were having. That is why DevOps was created, right? But it's bigger than just a team name. It's not just a team name, not just another team name. No, it's a culture on its own. So DevOps is primarily culture and practices, not a single tool, right? I think this has also been emphasized throughout our class today. Automation makes delivery possible and reduces manual error, right? It's also important we take that with us too as we wrap up for today. Teams share responsibility for software delivery and reliability. It's also important that we take note of that. It's not just developers or operations team that are responsible for delivery of the software. All teams, I would even say even product teams, every single team needs to collaborate to make sure that they share responsibility for software delivery and reliability. Right. So the goal is faster and more reliable software delivery. That is always the goal as a DevOps engineer or an organization that wants to adopt DevOps culture. The goal is faster and more reliable software delivery. Okay, time is fast spent, but I want one person to just take one takeaway from this. Just one person from these 5 things that we've mentioned to remember. Just take one, and then in your own words, you can just explain it in your own words. Right? Is it the goal is faster and more reliable software delivery? From everything you have learned today, right? Just pick one and then explain it, right? And anyone do that. You have anybody? If you have nobody, it's fine. You can go ahead. Okay, no problem. Our next slide, we're wrapping up. So this is our assignments. Right, before we meet on Saturday, I think our next class is on Saturday. Right, so I want us to choose one company, right? Be it Netflix, Spotify, any company basically. It can be a Nigerian company, OP, Access Bank, DC Bank, Child Deck, right? So I want you to do just like a one-page reflection. I don't want just verbal, right? We just when we meet next, it's going to be the first thing we do. How we start our class. So you just tell me the company that you chose, right? Now, what delivery or skill problem did it face? What skill problem did it face? I can give you an example. Child Deck, for example. Resolve the problem, right? And we all know what problem it is that Child Deck resolve. And what cloud practices or DevOps practices did it adopt? So some of these companies, they have publicly, right, how their DevOps structure is, their cloud structure is, right? How the cloud and DevOps structure, how did, how did they adopt it? What of these public practices did they adopt to make their process smoother? What benefit did they achieve for them, right? And then which principle today can you identify? Do you understand? So this is the assignment. I want you guys to um just do just mini research, right, before we meet again on Saturday. So when we meet in our next class, we'll go through it together, right? I would ask everybody one by one to let me know what their reflections are and the company that they choose, right? Yeah, I'll also send this as a text, right, so that we won't forget or anybody that missed it. Chigozie. So your hands are raised.
Yeah, please. The second question, what delivery or scale problem did you face? I think you should kind of explain it. I didn't get that.
Then right. Okay, so I'll give you an example, right? Netflix, for example, resolved a problem, right? So watching movies at scale is what they resolved. Before, I know you remember, we used to go and rent movies in CDs, right? If you want to watch movie back then, it's
Okay,
that you understand, right? So you understand now the issue Netflix resolved. You get, so just take a company and then
okay, I was thinking.
sorry.
I said I was actually thinking what you mean by the question. If the problem they face, like the company. So, but I understand what your question is now.
Yeah, thanks. Thanks for also
Okay,
clarifying
thank you.
that. I think my writing was even wrong. I'll send it to you guys later after the class and I'll edit it. Okay. Yeah, so in our next section, we'll be understanding cloud computing and cloud platforms. So what cloud computing actually means, why organizations use the cloud, infrastructure as code, platform as code, infrastructure as a service, platform as a service, and then software as a service. We're looking at AWS, Microsoft Azure, Google Cloud, and every other cloud computing provider that there is out there. We're looking at cloud regions and availability, and then exploring the cloud accounts. Okay, so if anybody wants to prepare for that also, you can use this as a preparation for the next class. So if DevOps isn't it, so what's DevOps? That's the final question. I'll answer the question myself. So removing barriers, DevOps is removing barriers between the people who build software and the people who operate it, using collaboration, automation, and continuous feedback to deliver faster and more reliably. Drop the charts. Okay, all right. Damilare is asking you guys to make sure you fill the attendance form. We've come to the end of our class for today. Is there any other question? Any question anybody want to ask before close for today? Any question? Any addition? All right, you go there.
Yeah, please. I don't know if we can have this presentation, if it's possible, so we can just maybe go through it on our own.
Yes. So I'll be sharing that too. And also the curriculum too will be shared with you guys.
Okay, thank you.
Okay. Any other thing? Any question? Any addition?
Yeah. Hello, sir.
Yeah, I'm as well.
Just a request. I don't know. I think we should be meeting on Saturday, based on the what I saw on the group. So the time, I don't think I will make it. I don't know if we can shift. I don't know. For me, I'm always busy on Saturdays. So if we can move it, down, a bit down, maybe from 6 or 7, I think that it will be fine for me. Or maybe on Friday. But I don't know for others, because majority carries the vote. Only one person won't decide. So that's just it.
Okay, good evening. Sorry about the noise and all. I'm on my way home. So for that, there's a recording. So you can always go through the recording and convey your question to the instructor, if you get what I mean. Sorry, did I communicate? Did you guys hear me?
Yeah. I got that.
Yeah. So I'm still trying to talk to Caleb to see how we can reschedule, if it's possible to reschedule. But
Yeah.
nevertheless, If you cannot join the class, there is a recording which you guys can go through over and over again. And if you have any question, you can always convey your questions to your instructor. At the same time, please, I just want to implore everyone to fill the form. Please fill the attendance form. It's very, very important. It's mandatory. Thank you.
Thanks, Danny. Yeah, it was very nice meeting you guys today. I hope I was able to make you guys understand the fundamentals of DevOps, right? So yes, we'll meet in our next class on Saturday. Although I think the time has not been decided yet. We have a time yet, but I also like us to carry out a poll, right? I can see Onyechi will actually wants us to say the time is fine, Jesus name. Yeah, I agree with that too. But I don't want any other person to be left behind. So I think we'll just carry out a poll between ourselves to see the best time for us. Okay. So yes, we're going to meet on Saturday and then we're going to be going through cloud computing and cloud platforms. So see you guys then. Cheers. Have a nice rest of your day.
Right. Thank you for today.
Bye guys. Cheers.